Hi everyone. I welcome you all for the course, for the lab course, Manipulator Robotics. And today's experiment is how to calculate inverse kinematics for RR manipulator and RP manipulators. Generally, inverse kinematics can be derived using algebraic method or numerical methods. Okay, so here and the geometric method is also there, but this one choose algebraic method. Okay, so we have taken RR manipulator and RP manipulator. But what does inverse kinematics means? If the end effector position is known to you, with that known end effector position and orientation, if you will be able to find the joint variables, means that is called as inverse kinematics. So inverse kinematics will give you a formula. In that formula you have to substitute your end effector, known end effector position and orientation. Then that function or that equation will give you the joint angle. So finding of joint coordinates with the help of end effector position and orientation is called as inverse kinematics. So end effector position is known to us, but we don't know what is the joint angle. So that joint angles are given by inverse kinematics. So this is the logic behind inverse kinematics. So let's take RR manipulator. So RR manipulator, the degree of freedom is 2. And here we are going to show the animation. So that is why for that we need a plot. Okay, so numpy, you know that. Then matplotlib is the biggest one or the versatile one in Python to experiment various plots. And here I'm going to take animation also, but the animation can be possible in Google Colab only with HTML. For that I have to import this. So these are the libraries. Okay, so let's start the code. So actually the code starts from here only. So let's go to the last line. Okay, so the last line is, yeah, your code starts here. Animate underscore inverse kinematics of RR manipulator. So this is the function. When you call this function, then it looks for it. So is there any function defined in that name? Yes, it is defined in this name. So definition, then this is the function name. So for RR manipulator, there are two link lengths, so L1 and L2. So we are defining it. So it is changeable. You can change also. Okay, but here first I have to ask the the user. Okay, what is your favorite X position and Y position? Because inverse kinematics means the X and Y is known to you. The end effector position is known to you. With the known position, you are going to find out the angle. So here RR manipulator means you have to find what is theta 1 and theta 2 with the known X and Y. So you have to ask the user what is their favorite or what is their target. So X position and Y position is given. So first you have to ask the user. The user will enter the value. Then for that you have to check. Okay, so it is like a Pythagoras theorem. So in Pythagoras theorem, you just see that the base and the height, so that both the lengths should be, greater than this hypotenuse length. So if that is the case, then so it is proper. But if it is not obeying that rule, then we have to say that the target is unreachable. So for that we have to check. We have to do the minimum check. So what is that check? So this is so I can say Euclidean distance. So you have to take the square root of x square plus y square. Then that value is d. That value should not be greater than L1 plus L2. It should be always less than only. If it is greater than, then we have to raise the error that this is the target is unreachable. Otherwise it is fine. So for that we need to give the check. Okay, and then in the regular class, we have seen what is the formula to calculate theta 2 and theta 1. So theta 2 is, so here when you apply the algebraic method, we found that cos theta 2 equal to this one. That is why. So cos theta 2 equal to x square plus y square minus L1 square minus L2 square divided by 2 into L1 into L2 cos theta 2, but theta 2 equal to cos inverse of. So in robotics we cannot directly apply cos inverse. You have to use arc cosine. So np dot arc cosine of this x square plus y square, because x square y square we get it from the user. L1 L2 is the length link length, and divided by 2 L1 L2. So this will give you theta 2. And also theta 1 is, so we have these two functions. So arc tan 2 of, arc tangent 2 of y comma x. So y comma x, the value from the user, minus arc tan 2 of, this is the formula we got while we solved the inverse kinematics algebraically. So if you want, the video is available for this inverse kinematics of 2R manipulator. So in that you can easily check these formulas. So we'll straight away put the formulas to theta 1 and theta 2. Okay. So now you have to print the value. So because x and y is received from the user, with the x and y value you have to do this. You substitute it and you have to display the angle. So for that, these lines are there. So this value is in radians. You have to convert it to degrees. So that is why this theta 1 degree, the variable equal to np dot degrees of theta 1. So theta 1 is in radians. You have to convert it to degrees. Similarly, you have to do for theta 2. And I want to print. So since I need the format, prescribed format, I have to use format. So theta 1 equal to theta 1 underscore degree. So theta 1 underscore degree means whatever degree is there, that will be printed, and it will be rounded to 0.2. 0.2 decimals. The 2 places after the decimal. Similarly, theta 2. So I want the output should be in this format. That is why, see the degree also in this form. That is why here f is put this formatted. Okay. So now what we do is we get the value from the user x and y, substitute in the formula, and that is printed. Okay, so the job is done. Your inverse kinematics part is done, but I want to see the animation. Okay, for example, for this x and y, if the angle is 45, theta 1 is 45 and theta 2 is 60, means I want to see the animation. Okay, so how it reaches the target? By undergoing various angular changes. So for that, I'm going to use frames. So here I'm going to use the frames as 100 frames, but this can be varied. So for the theta 1 which you derived from this equation, so you are going to split that theta 1 with respect to the frames. If you want 100 frames, then split the angle between 0 to theta 1 100 divisions. Likewise theta 2, but it depends. But if you have more frames, then you can see it properly. So this frames can be designed by you, chosen by you. Okay, so we need frames because from here only the animation starts. So for that we need a frames. Then we have to split the derived angle into this number of frames. For both the angles we have to do. Then we have to set the picture. Okay, how to set the picture? First we have to call the function figure, and these are the axes. Okay, so if you give these, means we'll be given the figure with the axis. Then you are going to set the limits. Okay, so the limit is from this to this. So here L1 plus L2, here minus L1 plus L2. Okay, for example, L1 is 1, L2 is 2 means 1 means, so minus 2 to plus 2. Similarly, you are going to set the limits for both the cases, and you are going to set this as a equal axis, and you are going to use the grid, and you are going to give the title, and then x axis, y axis normal. So this is called as you are setting up the plot. Okay, so this is done. Okay, so next part is we have to mark the target. So based on the xy value, so you are going to plot it x comma y comma, g for green and o for dot. Okay, o for dot, and then the marker size is 8. If you want, you can vary the size. So this point, plot the target. So the target is in green color, but it is in dot. You can put a square also, so it depends on the shapes. Okay, so next one is I'm going to create an empty link, because I'm going to draw link 1 and link 2, because animation shows link 1 and link 2. So first it should be empty. For that purpose, I have reserved a space for the link 1, but the link is in blue color, link 1, link 2 is in red color, and the line width is 2, but initially it is empty only. But once I initiate this animation function, this link 1 and link 2 will get the values. Okay, then I want to have a text. So that is why I am going to arrange the space for the text, so that every time when the angle is derived, so that it will be displayed. For that, this font size and the color is purple. Okay, so everything is done. So now the cursor will not check definition, will not check these definitions. Straight away it goes to the next line. The next line is animation. So in this animation we have already imported that function. Then this is the function animation, function animation name, and here while you call these function, you have to pass these information. Figure, which is we have already said, update, so it is going to refer the update. Frames, already it is 100. Init, it is going to refer the init function, and blit true means it's a block image transfer. Okay, so I mean every time, see, every time you call this animation function, it goes inside this and calculate the value, and it will redraw it. Okay, every time it will redraw the link 1, link 2, link 1, link 2. Every time it redraws. So that is 100 times, because the frame size is 100 times. So 100 times it will redraw. Okay, for that purpose we are using blit true. So block image transfer true, it is for redrawing. Okay, so whenever you call this function, you have to pass this information. So when you call this function, this says that okay, I have to check update, I have to check init. So now according to this, first it goes to init. Okay, so let's go to init. After calling this function, init is executed only once, so we are going to initialize, because we may have some initially we have reserved a place, but because every time once you finish the first frame, when you move to the second frame, the first frame values are there, so you have to clear it. For that purpose, initially this initialization. Okay, suppose if you are in 10th frame, so you have the 9th frame value also, so I have to clear it. For that purpose, this initialization. So link 1 dot set data, x and y is cleared, I mean there is no data, and then link 2 set data, I mean you have to set the data of this link 1 and link 2 as empty one. Then if there is any text value also, there also you have to clear it, because you are going to update with the new text value. So first you have to clear it, and you have to pass the value to this function, so that your link 1 is empty, link 2 is empty, angle text is empty. So it is empty now. Then it moves to the, because in the animation function you have update also, then it comes to the update. So in theta 1, you have already have theta 1 values frame. So here you have theta 1 value, see here. So already you have found theta 1, theta 2, then that value is splitted into frames. So the first value is 0, second value is maybe 20 degree or 30 degree, but each and every value we are going to take it. So in the update form, in the update frame form, we have to take the theta 1 and theta 2 based on the frame number. So here because there is no for loop, but indirectly the for loop is there. So the for loop is executed for 100 times. Okay, so for that you have to take the first frame value, then apply that theta 1 and theta 2 in the formula, which we have already I mean for RR manipulator, you know that x formula is L1 cos 1, Y1 is L1 sin 1, and x2 is L1 cos 1 plus L2 cos of theta 1 plus theta 2, Y2 is L1 sin 1 plus L2, and then sine of theta 1 plus theta 2. So these are the formulas you know already. Or from the OM matrix of the 2R manipulator, we have to check the translation part. There is a fourth column, first 2 rows, x value, y value. So likewise, we have to calculate x1, y1, x2, y2. So 0 to x1 is link 1. 0 to y1 is link 1. Then x1 to x2, y1 to y2 is link 2. So for that. So now we have got the values for x1, y1, y2. So we have to draw the link 1. So link 1 dot set data. What you're going to set? 0 to x1 for the first link, and y value also we know. Okay, we need it. So link 2 means from x1 to y1, x2 to y2. So once we first you have to take the first value, and then substitute that value in x, y coordinates, and you have to draw the link. So now the link is, I mean the link has the value. Next thing is you have to draw. Okay, and you have to update the text also, because this theta value should be displayed. Okay, so whatever theta you have got, that will be displayed. Okay, so once you have done it, you have to return with what is your link 1 value. Link 1 value means it starts from 0 to x1, 0 to y1. Link 2 means it starts from x1 to y1, y2, x2, y2. So that link 1 carries some value, link 2 carries some value, then angle text carries some value. So you are returning it. So it will take those value, it comes over here. It says that you have to redraw it. Okay, so based on the value, it will redraw the part. Okay, then again whenever you call this animation, then again it goes here. The previous value will be reduced, I mean will be removed. The previous values will be removed, and you have to update the frame. Every time the frame gets updated, and these values are calculated and link one is drawn. Okay, so this is how it works. So let's see the logic. Yeah, once you do that, then you have to call this function, I mean return the function, return this ani is the animation. So that ani is converted into JavaScript HTML for the animation part. So the logic is, first you have to declare the variables L1, L2, theta 1 and theta 2, and for 2-hour manipulator, for the 2-hour manipulator, the formula is given theta 1 and theta 2. So that value you can check it. Okay, so now let me run the code. So let me run the code. So once I run the code, it will ask for a x value and y value. Okay, so x value, let's say 2. Okay, then y value, let's say 1.1. Okay, so it will immediately, yeah, because it says the value is beyond that, because already we have, oh, I have given 1.1. Okay, so let's run again. So let's take 1.8. Okay, let's say 1.1. So it will, yeah, it calculates theta 1 as 11.28 and theta. So it has calculated. Okay, so this is the part for inverse kinematics. Now it is updating for the animation part. Okay, so already we have said that the target is in green color and dot. Okay, the thickness is 2. So now I'm going to run it. So you can see the link is moving every time. The link value, see, you can see the value theta 1, theta 2 every time the link value, I mean the link 1 link is drawn for the different values every frame. So 100 frames. Okay, so it keeps on doing it. Start from the frame 0 and ends at 100th frame. So what I want to show is, this is my target. So the inverse kinematics starts from 0 degree, both 0 degree, and it will update accordingly. So how it is updated? Based on the formula, because we have the formula already, so that is substituted, and for every time we have to calculate the link 1 and link 2. So that's why. So we can check again. Okay, so this is how it works. So this is the target point. So the same procedure is followed for RP manipulator. Here we need the libraries, the same libraries, and RP is, one is Revolute, another one is prismatic. So L1, and this is variable maximum prismatic extension. If you want, you can have 2.7. Okay, you can change also. So again you have to ask the user about the value x and y, then you have to check the same check, because this is a Euclidean distance. There should not be it should be less, it should not be greater. Okay, so again, and for RP manipulator we have already found the inverse kinematics. Theta 1 means it is arctan of y by x, and d2 is d minus L1. So what is d? X square root of x square plus y square minus L1. Okay, so this is the formula we have derived previously. So that formula we are going to use it, and once we know these values, substitute, and we have the theta 1, theta 2, that should be printed. So okay, so now we'll come to the animation part. Again frames, then theta 1, theta 2 will be splitted as per the number of frames. Then we have to make it ready for the plotting. So for that you have to keep the figure ready, axis ready, axis limit, so minus of L1 plus L2 comma L1 plus L2. So keep the axis ready, keep it equal, keep the grid ready, and give the title, give the label, everything, and your target point is green color dot. Okay, the marker size is 8. So now the target point is marked. Okay, so initially your link 1 is it is empty only, but it's blue color. Link 2 is red color. Okay, and Then it comes to the animation function. So the animation function, you have to pack these variables. What are the variables? Figure, update, frames, init, and blit. So blit is block image transfer, which is used to redraw it. So when this function is called, it is we move to init function. So every time it has to clear the previous value. So for that it will clear link 1, link 2 and the text part, and it return that value to this, and then with that empty value it moves to the update, and already we know that theta 1 equal to theta 1 underscore frames. Then d2 value is also given, so substitute in this formula. So x1 is l1 cos 1 and y1 is l1 sin 1, and x2 is, we know that, so x1 plus. So once you do the forward kinematics, you will be able to pick these values. So this is from the fourth column, first 2 rows values. So that values are given. So substitute those values in this. So now you will have link 1 value. So link 1 you have to draw from 0 to x1 and 0 to y1, link 2 also. So once you said that, you have to print that values also. For that, then so you have to give these informations to this link 1 this value, link 2 this value, and text also. So it carries these value and it will come back to this animation part. In this animation it says you have to do the block image transfer, so it will draw the plot. Okay, so once you do that, then it will return this plotting with the help of animation. So animation to JavaScript HTML. Okay, so let me run it. Okay, so target we can give it as 2, and then y1 is 1.9. Okay, so it will calculate the joint variables. Okay, so now once it prints the joint variables, it is ready for the animation. So we'll see the animation. So this is the target point. The target point, I think I have given 2 and 1.9 something. So here is the target. So this is the text. Okay, initially all are empty only. So now I'm going to start the animation, which means it takes the frames. You see, every time theta 1 and t2 will vary. And then the last value thing, I think 0.7. So see the prismatic point is increasing. Okay, because this is the variable point. So once it reached, okay, so this is the value. So here for this, the value is already we have checked. See, 43, 41.77, and D2 is okay. So this is how your RP manipulator works. So just gist of it. So here, first for RP manipulator, you should know the transformation matrix. If you don't know the transformation matrix, just use DH table, DH transformation matrix, and calculate it. Either you can use the DH table to calculate, or you can give the transformation matrix straight away. With this transformation matrix, then you have to find out the OM matrix. Why we have to find the OM matrix means because the OM matrix fourth column will give you XYZ, because we have to plot XYZ for the link 1 and link 2. For that we need that formula. Okay, so be ready with these things. And next one is you have to apply, you should know the formula to calculate theta 1, theta 2 or joint variables. So give those formulas and get the value of x and y from the user, substitute it, and you will get the target, and that value will be printed. But now animation part is, first you have to define the number of frames. For every frame you have to plot this x1, y1, x2, y2. So for that we have to use animation.func animation. For that you have to give figure, axis, and then init function, update function, and block image transfer. You have to give those variables. So it will take these variables and it will calculate the particular function accordingly. And then with the return values, this plot is redrawn again and again. Then finally it reaches the target. So this is how it works. So in this course, we have learned how to do inverse kinematics for RR manipulators and RP manipulators using algebraic method. Okay, thanks for watching.